Hey guys, welcome back. So, Mrs. Webb here. I just wanted to touch base very briefly today to chat with you about how to run a stoichiometric analysis using pH curve data. So, we've chatted about how the equivalence point in a titration happens at a pH of 7 for a strong acid, strong base titration. And in a titration, what we're looking for is that permanent color change of the type of the indicator that's in the sample, that 20-second permanent color change of the indicator. So the equivalence point in a titration is the qualitative observation that lets us know when we've hit that net ionic equation, the hydronium plus the hydroxide giving us the two waters. In terms of the end point in a titration, the end point occurs when it's the quantitative value at that equivalence point. So when we see this permanent color change, and this is labeled here as end point, because when we see that permanent color change here, what has happened is essentially one drop of titrant has taken us from this basic pH all the way down to this acidic pH. So our equivalence point happens right here. Probably I should actually flip-flop these two labels and put the equivalence point here and the end point right here. Because really the end point is going to be when we stop the titration and we see that permanent color change, which is also the equivalence point. But the end point, what we're looking for specifically is that quantitative value of how much titrant have we added into the sample at the equivalence point. And in this case, if we extrapolate a line down to our volume of titrant added, you're going to see that we had to add 13.50 milliliters of our sodium hydroxide to our 10 milliliter sample of hydrochloric acid in order to reach equivalence. And so if we wanted to do a analysis here in order to figure out what is the concentration of that hydrochloric acid, we would set up a chemical reaction. So we're reacting sodium hydroxide with hydrochloric acid. We're going to produce sodium chloride and water liquid. From the title in the pH curve, we know that the concentration of our sodium hydroxide is 0.500 moles per liter. And from the pH curve, by extrapolating down from the equivalence point, I was able to read from my graph, or the graph gave me, that the volume of titrant needed to reach equivalence was 13.50 milliliters at the end point of this titration. So that's the volume of sodium hydroxide that was added in order to cause this reaction to go to completion. We have samples in our Erlenmeyer flask that are 10 milliliters, 10.00 milliliters in volume, and we want to figure out what's the concentration of the hydrochloric acid. So you can see at this point it really is just a stoichiometric analysis, a unit analysis. We have, in this case, it's a solution to solution problem. It could really be mixed stoichiometry. It could be a solution to gas stoichiometry. It could be a solution to gravimetric stoichiometry. Really, it can involve any number of analyses, but you're picking out the concentration and the volume from the pH curve, and you're looking at what was the volume of your sample. So here we start with our sodium hydroxide. We use our volume of sodium hydroxide to cancel out the liters. We're going to use our mole ratio in order to get moles of hydrochloric acid, and then we're going to have 1 over the volume of hydrochloric acid. And this gives us a concentration of hydrochloric acid equal to 0.675 moles per liter. Okay. So it's similar to the analysis we carry out in the titration analysis with our data table, our observation data table that has the 3 volumes all within 0.2 of a milliliter of each other. except here we're just reading one volume off of our pH curve. And otherwise, it's a regular unit analysis problem. So I'll leave you guys here, quick little lesson. You guys will get a chance to practice some questions like this during class time. Things to really keep in mind is that in terms of definitions, your equivalence point is that qualitative observation of the permanent color change in the indicator. And the end point in the titration is the quantitative observation of how much volume of titrant did you need to add in order to see that permanent color change, right? And then remember that your pH for a strong acid and a strong base titration at equivalence happens at a pH of 7. So that's it, guys, for today. I hope you guys are doing well. Take care of yourselves. And as always, bring questions to class if you have them. And we will see you very, very soon. Take care.